Day 7, what have we got today? Hi and welcome to another episode. What we've got here is the PiHut Advent Calendar, Let It Glow. We're on day 7. As always, we get out the box. What have we got? What have we got? What have we got? Dear me. Little plastic bags. There's things. Right. So we have a cap for this slider. A variable resistor, I think these are known as. It's a slidey version though. I think that's what it's called. We'll find out when we do it on. I'm just going to put the cap on. There we go. Make it a bit easier to hold and slide up and down. And we've got 3 male-to-male jumper wires. So as always, let's get on with the website. Move the mouse around and scroll down. What have we got? Let It Glow Maker Advent Calendar Day 7. Time to slide. It's day 7 of the Let It Glow Maker Advent Calendar. Today we're jumping back to control component, something we can use to physically control our blinky components, with our code being the brains between the two. The slide potentiometer in your box will allow us to smoothly increase and decrease a reading, which we can use to change flashing speeds, colours, and more using analog signals. A great companion for LEDs and other blinky bits. Let's slide straight into it. Oh, the puns. Right, let's move the mouse around. There we go. So we've got the bits that we need. We already know that. Today's activities. Today we're going to learn how to use an analog slide potentiometer, including understanding what a potentiometer is, how they work, how the Pico can take analog readings from them, and ultimately how we can use those readings to make things happen with our coded LEDs. Whoa. Anyway, so what we got? Potentiometer is a variable resistor. Ta-da! I was sort of right. Right, our calendar already including a traditional resistor for the LED in box number 2, but that resistor was a fixed value. Blah, 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 blah. Basically, this is a resistor, and you slide it up and down, and basically as you're moving up and down, you're making a connection further along the connection that you're doing, and because of that, you're increasing or decreasing the length of wire that's in there, sort of, and that creates a resistance. I believe that's how they work. Anyway, the slide potentiometer in your box is 10K potentiometer, meaning it can set anywhere between 0 ohms to 10,000 ohms. Resistance is measured in ohms. I thought resistance was futile. Anyway, the way we're going to wire our slide potentiometer allows us to use it and send a varying voltage value to our Raspberry Pi Pico, which some special analog pins can read, convert, and provide a value we can use in our projects. That's cool. Quite powerful, these little Picos, aren't they? Think of a digital as a light switch. It's either on or off. Think analog as a volume dial on a stereo. You can twist the dial to gradually turn the volume up and down by smaller amounts. Or you could have said a dimmer switch and kept it all about the light bulbs. But anyway, our slide potentiometer can pass these analog signals in the form of voltage to our Raspberry Pi Pico, giving us a gradual input with a wide range of values for us to play with in our code. So we need to construct the circuit. As always, make sure your Pico is disconnected from a USB cable when working the circuit. You didn't tell us last time, did you? Right, it is though. It is. It's disconnected. Right, so we've still got the LEDs the way that we had them yesterday. Oh, so good. Right. Leave your RGB LEDs where they are, as we'll be using them later on. Your starting point should look like something like this. It does, because it's yesterday's gear, isn't it? It's the way we did it. To fit the slider, oh, we're going to stick it all the way over there. Right. You need to fit the legs so that they go across both breadboards. We suggest copying the leg holes as we use below, with 2 legs at the back and a single straight leg at the front. Okay, I think when they mean at the back, they mean at the top. I know what they mean really, it's sort of that way, but this is bottom, this is top. Right, so we need to pick the pins. So with the one, because Oh, let me zoom in. Got to do some zooming in. Dun, 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 dun. I'm expecting deliveries today, so I need to be getting on with making this video. Right, where are we? Come on, camera, you can do it. So there's 2 pins or legs at that end, and there's 1 pin or leg at that end. And what we want to do is have the 2 up there and 1 down here. So we need to get it, the 1 pin, and what's that one there? That would be F. So we need it in F30 on that 1 pin, and then the other ones should fit quite nicely in the other side of it. And get it to fit. Maybe not go down all at the same time. The legs bent a bit. I think the legs are bent a bit. So I'm just going to straighten them out a little bit, trying to line this all up. I forgot I was zoomed in again. Let's try again. If that goes there, now to bend the legs in a little bit, so you might see they're straight up and down. They don't fit. They do not fit if they are. Let's try again. Maybe try the top 2 instead. This is fun, isn't it? So these legs need to be pulled apart ever so slightly. I have pulled them apart a little bit. So we're trying for, on the top row with the 2 pins, I30 and I28, and get them to go in at all. There we go. Right, we've got it. So the pins up here need to be spread apart a little bit, and that one needs to be pushed that way a little bit. It does eventually fit if you wiggle it around a little bit though. Be very careful though, because you don't want to break the pins. And in the meantime, let's zoom back out again a little bit so we can see what we're doing. Little bit, little bit, little bit. Bit by bit. Right. So, I should maybe read instead of just going by the display down, shouldn't I? Connect the lower pin leg to, we've used, oh no, we've got to connect the pins up. Did read. This is me reading now, isn't it, for this next bit? Got too excited there. Right, you need to connect the lower leg to ground pin. We've used physical pin 28. Okay, so let's use some of the wires that we got yesterday. Actually, let's not use the ones we got yesterday. We've got wires here, we got today, but we've still got plenty from the other day. So let's carry on using them for now. Let's use the brown one for that first bit. So let's scroll back up again and see where we've got to go. Connect the lower leg to the ground pin. Okay, so are we on J30 of the lower board? And we want to go to what did it say now? Physical pin 28, which is that one. It's in line with the Raspberry Pi logo. So that's actually I13. So we'll put that in. No, sorry. Yeah, I13. So that's that one. Let's take an orange wire and we'll connect that top left leg. So we need F30. We need to come all the way across, and it says for the 3.3 pin, which is physical pin 36, but that is on the lower board I5. I'm sorry for a bit of reading. I still haven't put my reading glasses on. Very silly thing. I should definitely do it. Oh, not another orange one. Let's take another green one. And for this is for the top right pin. We need, that was F28. And we need to come down to a couple of pins further along from this one, which is I7 on the lower board. Right, so we have that now. I'll put the slider all the way to the, well, slider's in the middle, I don't think it really matters at the get-go. Your breadboard should look something like this. It does, doesn't it? We've got it going now. Activity showing the slide. So let's start the simple program that prints analog values. We're specifically using GPIO28 as this one of the Pico's ADC pins. But what is ADC? Quite frankly, I was asking the same thing. What is an ADC? If you look at the Pico pin map again, you'll see that there are 3 dark green ADC pins available on the right. GPIO 26, 27, 28. Physical pins 31, 32 and 34. Okay, let's have a quick look at that map. Oh, got to download it, haven't I? I'll open it and drag it across. Hoping there's nothing else for you to see. There we go. Let's just have a quick look. There we go. So dark green, it said. Here we go. ADC 1 and 2, and that one there is also part of all that, and that's the ground for that. But that's the ones it was talking about. So 31, 32, and 34. Is that what it said? It is, isn't it? 31, 32, and 34. Right. An ADC is an analog to digital converter. Oh, of course it is. The ADC pins on our Pico have a special ability to being able to convert analog input to digital form we can use. We have to import ADC in our code to use this feature. Note, you'll also spot an ADC VREF and G&D pins, but we're not going to use those pins in this calendar as we don't strictly need to use those for our example. We'd rather not overcomplicate things whilst we're still learning. Fair enough. Yeah. Wish it would stop automatically scrolling. Okay, let's move on to the code then. The code below imports ADC and sets GPIO28 as an ADC pin. Then we'll set a while loop which prints the potentiometer's value every 0.3 seconds. The read_u16 part does this, taking the varying voltage applied to the pin from the potentiometer and scaling this range to a usable output value between 0 and 65,535, which is what I told you yesterday with the 256 or 255. There's a special number that you'll always come across when you're doing things on a computer. 0 to 65,535 is also sort of counted as being 65,536. Have a play around with binary, you'll start to see what I mean. But obviously do that after today's lessons on this. I'm just trying to keep things basic as well. But for those that want to get technical, the PDC is 12 pin. However, the micro scales this in 16-bit range from 0 to 65,535. So there we go. That's a bit technical. It's using 12-bit instead of 16, but that's fine. Calculations can all be done, and the more that it does it for us, the better. Run the code below and try turning the dial. What dial? Turning what dial? There is no dial. It's slide the slider. Come on, PiHut. Dear me. Right. As always, we need to get this plugged back into the computer. So that's that done. Hopefully nothing goes pop in the meantime. Let's balance the wire up. There we go. As always, press stop. Gets it up and running again. Let's make sure I've got the code. Press copy. Right click. Paste. That's quite a small little thing, isn't it? Run the code below and try turning the dial. Watch the values go up and down as you move the slider. Turning what dial? There is no dial. Is there a graphical dial? No? There we go. So it doesn't stay still then, does it? It's not exactly a particular value. So at the top, 65,535. And it's not like a set value, is it? It's jumping around. I'm not moving the slider. Apart from I am moving the slider bit. I noticed with the slider in the middle, there's a middle point. It sort of clicks into place. So even stuck in the middle place, it just dances around a little bit with the values. So yeah, and all the way to the bottom is actually maybe hitting 384, 320 sometimes. I can understand maybe why the values are bouncing around a bit, but it means though if you're going to do something, you would have to pick a range. You'd have to check between, is the number between blah 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 and blah blah blah, which is slightly higher than the other blah blah blah, so that you could, you get to a certain part and then like a green light comes on or something. Anyway, we know we've wired things up correctly. That's the main point for this. So we stop that one from running. The sliding color changer. Our slide potentiometer gives a value of a wide range depending on which position it's in. So let's use it to drive some if and elif statements, this time with conditions that look to see if the value is higher, lower, or between a set range to control the color of our LED based on the value, which is pretty much what I was saying. Right, less than, greater than, or between. In our example below, we check to see if the analog reading is less than 20,000, between 20,000 and 40,000, or greater than 40,000. Okay. And then it talks about the operators. Now, operators are these things here, as in less than, equal to. That's what that means. And if the arrow's going the other way, it means greater or equal to. You could also just use that sign by itself. But as in if you did that though, it would you would miss out a certain number, because as in if you would have to put greater than 29,999 if you wanted 30,000 above. So it's sort of easier to do greater or equal to 30,000 instead of playing around with just one less. To make our statement look at the value between numbers, blah blah blah. So 20,000, we already know what they're trying to do. So we're doing the RGB LED, which they should really refer to as the GRB, because that's what it is, using the red, amber, green color variables. Right. Copy the code over to Thonny. Then why not try adding more elif statements, splitting and range even further to add more colors from yesterday? Okay, we might give that a go, but I might just leave you to do that. And if you get stuck, you can always come across the Discord or ask in the comments, and then I'll tell you what, I'll create a bonus video for people that are a little bit stuck if I do get some comments about it. Right, let's run that script. So we have red, we're controlling that one. Let's turn the brightness down again so we can get to see. There we go. It's definitely red. And we're going to move the slider. It's sort of a funny yellowy green. It says green, doesn't it? But then, oh, there's green. That's supposed to be amber. More of a yellow. We had a better amber yesterday. But anyway, that's what they're saying is amber. So we've got our traffic lights now. We could control with the slider, we could stand it and control some fancy traffic lights. So that's nice, it works. Let's stop that then. Are we going to change anything? Got all the colours, are there all the colours up here? No, they're not. Well, as it says, if you mess around a little bit and add in different colours, that should be fun enough to do. It should be easy enough to do. If you get a bit stuck, just let me know. The slider fader. Let's now make use of the analog reading to control the GRB value of 0 to 255, if you remember, on our LED, allowing us to fade it in and out using the slider. Rather than using if statements looking for a range of values, we'll inject a number directly into the GRB LED code. However, we need to crunch the numbers here because our analog range is 0 to 65,535, but our GRB value only runs from 0 to 255. To do this, we need to convert and use the round function. Hold on to your socks, folks. It's time to get some maths. Okay, right. Here's how we'll convert the ranges. It might be worthwhile to follow along with a calculator to see for yourself. So we need to take the analog range 65,535 and divide it by the GRB value 255, which leaves us with 0.003891050583656. Ooh, right, every time we take an analog reading, we need to multiply it by that number. So let's say we take a reading of 40,249. This would be blah, 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 multiplied by 0.00389, blah, blah, blah. And that would leave us a value of 156.61, blah, blah, blah. Our GRB code doesn't want decimal places, floats, as in floating points. And the reason why it's called a floating point is because if you move you can actually move the decimal point or the period, depending where in the world you're from. You move that around on the scale of numbers. You can see my shadow there, scale of numbers that you have. You can multiply by 10 or divide by 10, or multiply by 100 or divide by 100. And all you got to do is move the decimal point or move the period. But this isn't a math lesson. Well, it sort of is with this bit. Anyway, so we need the round function so that it takes the 156.6 and then it rounds it up, because that 0.6 is greater, it's greater than 5, it ends up becoming a 7. It would round down if it was, say, like 0.4, it becomes just 156. Our code can automatically convert our reading data sliders. Now, I don't know if the code will do it like that, because I can't remember with Python if it's just a round and it automatically pushes it up. But normally in maths, that's what you would do. And yes, there's more than one maths, so it has an S. the code, we create two variables, one for analog reading, another one for converted RGB value. This allows us to print the original values next to our converted RGB value to see what's going on. So we can print it by doing this, basically. In the quotation marks, that's the text that you want to put there, and then you do a comma, and then you put the variable name afterwards, and then it will print like that. So it'll end up being, for example, RGB : space, and then the value will be printed afterwards. We could have shortened our code by taking analog reading as part of the same line as well, but it's complicated enough without adding more on a single line. For example, they could have done all of this, and it still would have worked, but if you're not used to reading code, it can be a bit confusing at first. So as always, let's delete the last lot of code, copy this code, stick it in, and basically you should be able to start reading the code a bit easier yourself now. And obviously it has got these hashtags so that you can read on what's happening. But it's just basic maths, in the end. So GRB value, I wish they would keep to a standard, because it said RGB value, it should actually be GRB value. I don't know, RGB. Yeah, whoever's written the code has forgotten when they've written up all the text. So try not to get too confused, because they're not keeping together on what's what. But basically, this is how it works. It's converted the values. Lighting LED is converted to BRG values. Is it BRG values? It's GRB values. I think someone was a bit tired when they were typing all this up and coding it. Yes, try not to get too confused that they keep jumping backwards and forwards. They mean GRB, and that's that. Right, so let's press play. So we have blue, and we can see in the code there though it's doing its best of converting the values. So we'll slide around, and we can see now that we end up with light blue. And as we move up, it's increasing the values to a point that really on camera you can't really tell. About halfway point, that's about as bright as it gets on the camera, and that's it. You don't see it getting. Oh, I do actually see it get a bit brighter, don't you? You see there's more of a glow around it. But yes, so let's turn it as far down as we can, and because it's not actually hitting a direct 0, it's down to 1, which is basically off but not, and jumps up to 2, sometimes 3, maybe even, yeah, keeps jumping between 1 and 2, which is a little bit, so it looks like it's flashing, and it shouldn't be doing that. That's just so what you would actually have to put into your code is after the lower it is, just class it as being off. So check for 1, and then don't put any power through to it. If you were going to really do this for real, you know. So let's stop that. That's the code. We've looked through it. Right, so now we're going to use it as a slider flash speed control. Blinky isn't blinky unless it blinks, so let's use our slider to change the speed of the flashing LED. We'll do this by creating a simple variable and directing use. We'll also make this little more interesting by adding a random color changer for each flash as well. Oh, how very festive indeed. That's how they've been sarcastic themselves, aren't they? Tip: using variables for time delays can be useful in other ways too. If your code includes lots of similar delays in different places, updating a single variable can save you a lot of time. For example, time.sleep variable speed throughout your code, then update my variable to whatever you want that delay value to be, and it'll change everywhere. It's a clever way of doing it. I don't know if they're going to mention in it. Basically, they're mentioning about the whole thing of dividing 65,535 by a number, so you get a range, sticking them into the GRBs. Oh dear me, that's not RGB, it's GRB. It's right there in the name. I wish they would sort their life out. Trying to teach people here. Right, so that's actually GRB, remember, not RGB, hence the whole thing that they told us the other day. Right, and so here's some code that explains on what's happening. Now, they haven't said it, but I'm going to say it. Since it's mentioned that there's flashing, and yesterday they gave warning about possible problems for people with photosensitivity epilepsy, please be very careful. Again, I'm saying please be very careful. So let's have a cut and, well, do what we do, delete the old code. And I'm going to say it yet again, please actually type this stuff out, because you get used to doing it. Seriously, it helps make it become muscle memory in your mind and in your fingertips. See this bit though where they made a mistake in talking about it up, where was it? Where have we gone? Where's the example code? There we go. See this GRB LED.fill? It's actually put in correctly over here in the code. Right, so let's have, we've got that code now, so we're going to press play on it. So there we go, we've got a flashing LED. and it's quite low, so it seems the higher up we go, the slower it changes in between the different colours. It is actually doing a range of colours now. I'll bring it down to the bottom though. It's being like a strobe light, it's going so fast. It near enough looks white. There's like pink and red. It near enough looks white, it's doing it so fast. So that one works. Press stop. Day 7 complete. Woohoo! So there was a lot to learn today, in a little bit of mathematics, a little bit of figuring out how this slider works, and it's realizing it's not, it doesn't actually give a dedicated value as you're sliding it up and down. So you have to pick out ranges, and those ranges in themselves can be a bit flaky because stuff. So if you're going to use your own code, you're going to have to make sure that the lower half of it just sends out a 0. You know, if you bring it all the way down to the bottom and you're trying to do brightness. So I was waiting for it to change its glow, and of course it's not turned on right now. And that was a different program anyway. But yes, as I will say again, if you get a little bit stuck, come across to the Discord channel. I'll try to help you. I'm around most days. If not, just leave a message in the comment and I'll try to help you that way. And if there's a fair few people, I'll make a bonus video. Don't forget to check out the Patreon links. And as always, don't forget to hit the like button, the subscribe button, and that notification bell so you find out when the next few days are coming up. And as always, happy gaming.